Hello, geometry students, and welcome back to another video lesson. Today, we move into proofs. Proving triangles are congruent, going through the different steps to show how they end up being congruent. And so this is another important video where you're going to need to take some notes and think about some of the things we've done in the past for proofs. Eventually, once we can prove that two triangles are congruent, we do hop down to using those triangles to prove that parts of the triangles also are congruent. So please make sure, again, take notes, follow along, and let us know if you got any questions. Here are those 4 triangle congruence theorems that we learned about last week. SSS, or side-side-side theorem, SAS, which is side angle side, ASA, which is angle side angle, and then AAS, which is angle angle side. Those are the 4 main ones that you definitely want to make sure you're looking out and watching for, because it's those that help us prove two triangles are congruent to each other. Once we have triangle number, or let's just say ABC, is congruent to triangle XYZ. Once we know that's true, because of one of those 4, there's something else we now are able to do, which makes why are these 4 so important to us. But once we know the two triangles are congruent, I can then say that angle A is congruent to angle X, or that segment BC is congruent to segment YZ. And I'm allowed to say those things because of the CPCF theorem. Corresponding parts, incongruent figures. Once we know the triangles are congruent, we know that their corresponding parts are congruent also. So we can't use this CPCF theorem, though, until we know that the triangles are congruent, which is why these 4 are really, really important, because we need to use them to be able to then prove different points are congruent. And so we're going to focus a little bit on how can we utilize these 4 to help us come up with proofs. Now, the first thing to understand in working towards the proof is to look at a diagram and figure out what congruence statement allows us to say the two triangles are congruent, right? This is like what we did last week. So how can we say that XZW, so I'm going to put that in the first one, XZW might be congruent to the bottom half, but I've got to figure out what matches what down here, and then I got to figure out also what theorem allowed us to say that. Well, if you notice in these two triangles, they share this side, which makes this third side congruent to these other sides. Therefore, we do have SSS, side, side, side. But I've got to figure out, how do I write this? Well, X, which is where the one side and the two side meet, is the same as Y, where the one side and the two side meet. So I better write Y first. And then Z is where the one side and three side is Z, which means W is W. Right? But it's understanding what picture you have that hopefully helps you figure out the congruence theorem. Look at the second one. We have a side and an angle, but remember in this picture that we also have vertical angles. This angle is congruent to this angle. Therefore, we now have an angle to a side. Angle, angle, side, which was one of our valid theorems. Angle, angle, side. But I've got to figure out the actual triangles. Now I'm going to start with G because it's got one mark. G, and then I'm going to go to the second mark, which is I, and then I'm going to go to the one that has no marks, which was H. And then I'm going to go over here. G had one mark, so over here, J had one mark. And then I went to I, which had two marks, which is also I, which means K has no marks, which lines up with H. So these notations and the order are essential to us writing the proper notation and the proper congruence theorems. Now, on the next slide, I want you to look at it carefully to try and figure out what other pair of sides needs to be congruent and marked congruent so that the two triangles here are congruent by SAS. What other pair of sides? Side to an angle to a side. And if we go around the pattern, side to an angle, it needs to be this side, side to the angle to this side. So somehow we needed to show, or we needed them to give us, that FE was congruent to MN, because they told us it had to be side, angle, side. Now in the other one, a very similar picture, but they want us to mark a pair of angles so that we could use ASA. Well, ASA stands for angle, side, angle. So angle, side, then the next angle. Angle, side to the next angle, which means angle D would have to be congruent to angle L for us to have used that properly. And so that's the beginning to what we're doing here with proofs, is we're trying to figure out, maybe, do we have another side or an angle that we might need to prove is true so that we can then say the triangle is congruent, right? So we got to figure out what we might be missing. So here's the first example. Okay, you might want to just pause for a moment and write this down. Now, they're giving us that angle B and angle D are right angles. BA is congruent to DE, and BC is congruent to DF. So I'm going to mark that on the triangles here. B and D are right. So those two are congruent because they're both right. And angle BA is congruent to DE, and BC is congruent to DF. They want us to prove that the two triangles are congruent. Do we have enough information? A side to an angle to a side to an angle to a side. Is side, angle, side a valid congruence? And it certainly is. So in this one, we can go right to the end to say that triangle EDF is congruent to triangle ABC. What is our justification? What theorem did we show was true? Side, angle, side. Right? Because they gave all of the information to us, we could go right to the end. Now, that's not always going to happen. For example, here's number 4, or whatever example you want to call this, where we are told that AB is parallel to XY. Ding, 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 ding. Parallel. That better let you know something's happening here. So parallel. And that AX bisects BY. We need to prove that these two triangles are congruent. So we start with the given. Always the given. And I'm going to focus on this one. AX bisects BY, okay? And when that happens, that means that this segment, they put a red mark there, is congruent to that segment. So it's already given to us that we know that. So we have a side is congruent to a side. That's all we have right now is an S. All we have is an S. That's it. Well, if you notice, is there anything else in the picture that we can say? Well, one of the things we talked quite a bit about was these two angles. Those are called vertical, or VAT, vertical angles theorem. Vertical angle theorem, VAT. And we know that those two are congruent because of that. So now we've got to spell it out, though. And I can't just say angle P is congruent to angle P, because it's two different angles. YPX, angle Y to P to X, is congruent to angle APB, if I follow the order. All right, so now we have a side and we have an angle. So we need one more piece of information. We either need a side or we need an angle. Well, we have to go back to this, the parallel. Remember the ding, ding, ding? That parallel piece is key. When we see parallel, right? We talked about this. When we see parallel, we should be thinking alternate interior angles or alternate exterior angles. One of the two. Ironically, we could do this one two different ways, right? If I know that AB, let me just pull this off, AB is parallel to YX. There's the top of that diagram and there's the bottom. I'm just going to draw this one right here. That line from B to Y, which means this angle is congruent to this angle. This one is congruent to this one. And I'm going to write that as step 3. Angle B is congruent to angle Y. If you look at this picture, those are alternate interior angles. AIA, alternate interior. And now if you look at those two diagrams, we have an angle to a side to an angle. An angle to a side to an angle. Angle, side, angle allows us to say that those two triangles are definitely congruent. But we had to show that those two other angles were congruent first. One by vertical and one by alternate interior angles. How did I know to use alternate interior? Because of the parallel lines. All right. Now, the last example is quite a bit different, quite a bit. Because they're not asking us to prove the triangles are congruent. They're asking us to prove segments are congruent. That segments are. And notice KE is on the left triangle and TE is on the right. Well, in order to prove this is happening, the step before this is to show a triangle is congruent to a triangle. I can't show that those two pieces are congruent until I show the triangles are. So if we focus on the given, KI is congruent to TI. So this is given. And it tells us that IE bisects KIT. So this little angle up here is congruent to that little angle there. So we've got a side and an angle. A side and an angle. That means we get a side and an angle. That means I need another side to be congruent, or I need another angle to be congruent. Well, we don't know anything else about this shape. Yeah, it looks like a kite, but it doesn't tell us that. Certainly doesn't tell us that. So I don't know anything yet. But they do share a common side, i.e., so number 2 is going to be that segment IE is congruent to itself. Segment IE. What allows us to say that? That is called the reflexive property. You want to make sure that you have that down somewhere. That's the reflexive. Well, now that I know that IE is congruent to itself, notice how we have side to an angle to a side. We have SAS. Side to an angle to a side, which allows me to say that those two triangles are congruent. Triangle KIE is congruent to triangle TIE. We are allowed to say the triangles are congruent because we showed SAS was happening. And once we have showed that the two triangles are congruent, that was the step before, we can say that their parts are congruent. Or in this case, the part KE is congruent to the part TE. And once I have the whole figure congruent, what allows me to show that a part is congruent? That is that CPCF, corresponding parts in congruent figures. And anytime they ask you to prove a part is congruent to a part, that's probably going to be your last step, congruent corresponding parts in congruent figures. The step before that will typically be showing that the two triangles are congruent as well. All right, this video got a little bit long, but these proofs are really important. We're going to spend a lot of time practicing them. So if you do have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.